Hello everyone, I am again with you with a sequence of the topics. So in previous video, I think you have watched that video of local maxima and minima. It was all about the introduction of local maxima and minima, and I will recommend you, it is necessary to watch that video before this topic, because in this video, that is the part 2 of local maxima minima, I am going to do some important questions so that you know what is the technique to solve a question and what type of question you are going to face. So number 1, I have taken a question, find the local maximum or minima if any. It means if local maxima and minima exist. You know, in monotonic function, no local minima and minima exist. So if any of the following functions, I have taken 2 functions, and also find the local maximum and minimum value. So starting from this question. So I will also tell you that how you will have to make a choice of first derivative test and the second derivative test. Though it is not mentioned in the question by which method you have to do this question. So now it is up to you. You can either use first derivative test or second derivative test. I will tell you the strategy how to make. So come on, let's see this question. We have this question, x upon 2 plus 2 upon x is, and when x is greater than 0. Thank God x is greater than 0, because what would if having x is 0? Because at x is equal to 0, this fraction will become undefined and we cannot define the function at 0. So it is already given that x is greater than 0. So now whether it is first derivative or the second derivative, we need to find derivative of the function. So we find derivative, that is f dash x. So in second derivative, I'll tell you that instead of assuming fx, you assuming y. So suppose I have assuming like y, x upon 2 plus 2 upon x. So now I am going to find dy upon dx. So the differentiation of x is 1, that is 1 by 2, and the differentiation of 1 upon x is minus 1 upon x square. So this is the derivative. For stationary points, we need to put dy upon dx equal to 0. That is, we will put this expression equal to 0. So now, make a line. So 1 by 2 minus 2 upon x square equal to 0. Now LCM x square minus 4 upon 2x square equal to 0, and it is not 0, so it can be multiplied. So, and we have x minus 2 and x plus 2 equal to 0, so that we are having 2 roots, that is minus 2 and plus 2 and minus 2. We will not take this root. Why? Because we have given x is greater than 0. So in our domain we have only one stationary value, that is x is equal to 2. So this is the only stationary value. It means at x is equal to 2, tangent is parallel to x axis. Now there may be arising 3 cases. One, it may be local maxima, it may be local minima, and it may be point of inflection. So to check in second derivative, we need to find second order derivative. So now, it was a first derivative. So we will start here from and we will get second derivative, that is d2y dx2. So now the differentiation of half becomes 0 minus, and 1 upon x square, differentiation will be minus 2 upon x cube, and it will become 4 upon x cube. So finally it is 4 upon x cube. Now we have to check the sign of d2y dx2 in second order derivative. So, and what value? At x is equal to 2. So sign of second derivative at x equal to 2. So 4 upon 2 cube, which is 1 upon 2, and which is obviously positive. So d2 by dx2 at x is equal to 2 is positive. So function is, that is, fx has local minima at x is equal to 2. So because our second derivative is positive at this point, it means we have local minima, and we need to find local minimum value also. What is the local minimum value and how can we get local minimum value? So we will put this x is equal to 2 in the function to get local minimum value. So how to write? See, we will write like this. Okay, I am erasing it now. So because I need to find local minimum value, which is called f minimum. So at what value? X is equal to 2. So I will get 2 upon 2 and 2 upon 2. So this is, solving 2. So this is the locally minimum value of this function. So by differentiation, we know in this curve we have one stationary point. It means whenever we draw the graph of this function, we will have one point on which tangent is parallel to x-axis. That is one stationary point. And at that stationary point, there will be a local minima. And what is the local minimum value? We have got now the turn off. So this question we have done with the second derivative task. So come on, question number 2 we will do. So we have second part of the previous question. I will do this question with the first derivative test so that you can understand how to apply first derivative test. So let's see. I have done some of the work that I have got the first derivative, that is f dash x. I know you can find it easily. So this is the first derivative with us. Now you know, in local maxima and minima, to find a stationary point, we need to put this derivative equal to 0. So for stationary points, f dash x equal to 0. So if I am putting this expression equal to 0, so what value I am getting? Number 1, x is equal to -1. Then x is equal to 2, and from this bracket x is equal to 2 by 7. So I have 3 stationary value in this part. So I will mark all these values on the number line according to their order. So -1 comes first, then we have 2, then we have 2 by 7. Now you know 2 by 7 is it will be in between, that is, this is 2 by 7, then I have told you that you have to arrange these numbers according to the order. So 2 by 7 is between 0 to 1. So 0 will be here, you can mark, and you will have 1 here. Then after 2 you will get 3. Before -1 you will get -2. So our main points, these are our stationary points. These are our stationary points. So first of all, I need to check at x is equal to -1. So where I am checking? Number 1, at x is equal to -1. What is this point? Is this local maxima, local minima, or inflection point? So at x is equal to -1 I am checking. So I will take some value. I have to check the sign of the derivative before -1. So before -1 there is a point -2. So check on -2. Suppose I am putting -2. So you just need to check the sign I am telling you. So -2 plus 1, -2 plus 1, -1, whose square is positive. The positive into. Then -1, -2 and -2 will be -4, whose cube will again minus into minus. Then if you are putting -2 here, so 7 into -2, -14 and -2, -16, it will also be negative. So at -2, this is positive, negative and negative. So overall plus minus into plus, then plus. So overall minus 1. The sign will be positive of the derivative. Now after minus 1, so I am taking this point 0. So if I am putting 0 here, that is 0 plus 1. So it will be positive. 0 minus 2 and cube, that will be negative. Then 0, 7, 0, 0 and minus 2, that will also be negative. So now negative, negative, positive and positive, again positive. So we have positive. So you know, before minus 1, the sign of the derivative is positive, and after minus 1, again the sign is positive. It means sign is not changing. So this is neither local maxima nor local minima. So this is the point of inflection. So this is the point of inflection. So at x equal to 1, minus 1, what is the point of inflection? Because the sign of derivative is not changing. Now come to the next point, that is at x equal to 2 by 7. At x equal to 2 by 7. So before 2 by 7, there is a point 0, and I have already checked the sign was positive. So it is positive. Now after 2 by 7, there is a number 1. So I need to check the sign of the derivative at 1. So 1 plus 1, 2 and whose square is, so positive I will get. Then 1 minus 2, negative. Then 7 into 1 minus 2, it is positive. So 2 positive and 1 negative will become negative. So now before 2 by 7, sign was positive, and after 2 by 7, sign is negative. So it is changing plus to minus. So it means if the sign of the derivative is changing from plus to minus, it means it is local maxima. So at x equal to 2, local maxima. And what would be the local maximum value? So f maximum will be, you can put 2 by 7 minus 2 to the power 4 and 2 by 7 plus 1 cube, and you can get. Now it is also to check at x equal to 2. So now before 2 the sign was negative, already we have checked. What is the sign after 2? So if I am putting 3 here, so 3 plus 1, this bracket will positive, this bracket will positive, this bracket, all bracket will be positive. That is after 2, the sign of the derivative is positive. So now passing through 2, the sign is changing minus to plus, and whenever sign is changing minus to plus, so there will be local minima. So that is at x is equal to 2, local minima. So the first point was point of inflection, then this point was local maxima, and this was the point where local minima occurs. So I have taken a question in which you have seen all the situations like point of inflection, local maxima and local minima. Now in the next question I will take a trigonometric question and I will solve how to find maxima and minima. Now see this question. Fx is equal to sin x plus cos x, and x is given between 0 and pi by 2. So we will have to check where the point is locally maximum or locally minimum, but our domain is between 0 to pi by 2 only. So first of all find derivative. So I am going to do it with the second derivative, then I will assume it y. So I will find the derivative, that is cos x and minus sin x. And now for stationary points, dy upon dx will be 0. That is cos x minus sin x will be 0. You can say sin x is equal to cos x, or you can say if I am dividing with cos x, that is tan x is equal to 1. And you know tan x is equal to 1. Between 0 to pi by 2, there is a value pi by 4. It means we have got the value of x, which is pi by 4. So this is the only stationary value in this interval. Now I will check whether it is the local maxima or local minima. So to check it, I need to find second derivative. So I will find it d2y dx2. So cos x differentiation minus sin x and minus sin x. So already it is So now I will find the second derivative at the stationary point, that is pi by 4. So in place of x put pi by 4 and pi by 4. So sin pi by 4 1 upon under root 2 minus 1 upon under root 2. Thus it will be negative. Before adding I am telling you it is negative because two negative number will give the negative result. So I need to check sign only, not value. So the sign will be negative. So because this point at x is equal to pi by 4 is less than 0. So y is maximum at x is equal to pi by 4. So this function is having one stationary point in this interval, and at that stationary point the function has local maxima. And what is local maximum value? So I can find like this, f maximum. So I need to put pi by 4 in place of x, that is sin pi by 4 and plus cos pi by 4, that is 1 upon under root 2 plus 1 upon under root 2, and after solving I will get under root 2. So this is the locally maximum value of the function. So in next video I will teach you about absolute maxima or minima. Thank you for watching.